focus for writing this year has been on lab write-ups. Students are assigned to do a lab write-up based on what they're actually doing. It's not easy to do to write what you do in a procedure that somebody else can actually follow. This would be the actual lab from lab aids, the procedure they had to follow, and the percent error in this particular lab was around 10%. On the back, associated with the lab, was the periodic table of mistakes. Students had to go and find mistakes on the periodic table like OMG is not oxygen, JK is not potassium, and then they had to list them here on this page. Alright, very good. 1S1. So pick somebody, Cody, to do carbon. You get to be mean and pick somebody.
Don't do it. 2. 2P2.
3S6.
3S6.
3P4.
3P4.
Everybody agree with that? Everybody agree with that?
I think that's right.
No, you can't have an S6. Nice. S can be a Okay, very good. Alright, can somebody do iodine, ion, 1 negative? So once again, when you form the ion, you're trying to behave like a noble gas. Yeah, Jake?
Could you just put X?
You could.
Magnesium, 2 minerals important for your health are examples of alkaline earth metals. Because magnesium is solid and relatively light.
Yeah. The purpose, once again, is for you to be familiar with the metals that are associated with the alkali group. And if you notice, this follows along into the next chapter. Some of the things we've been talking about as far as like electron configurations. Marked on there 1 milliliter.
Oh, I read that.
Yeah.
Definitely.
Cloudy there.
Cloudy and white.
Oh, yes.
Yeah, we had that.
Okay. It's like kind of clear, clearish white.
She's got this. 1S2 type thing.
Oh, that one.
Yeah.
Oh, let's just.
Very good. Why earth metals have a specific group, and they will, Simon, they will form bases in the presence of water. So you're going to examine some characteristics of the alkali metals today in this lab. They form bases, and anybody know what a base is? A base is an electron donor. So I'm going to write that down. Bases are electron donors, and they are proton acceptors. Everybody know what a proton is? Proton. A positive hydrogen ion. That would be a proton. Right? So a proton doesn't have an electron, so that's why it's positively charged. So they are hydrogen ion acceptors. That would be bases. Now, why do we like to put bases in batteries? Why should you put a base in a battery? Because they're electron donors. So in a battery, you care about what? What do you care about in a battery? Electrons. All right, so let's get started.
So what do we do about point five?
Yeah, so once you get your point 5, go to the next chemical. So we're just following the data sheet, the procedure. So the next one should be, if we're following this, we use magnesium nitrate, and then we should be using potassium iodate. So if you look on here, it should see, actually they want you to put them in order. Next would be calcium nitrate, so you're just going to follow along in order. Well, follow the procedure. It's putting the chemicals in a row, so just follow the procedure. You're going to write what you do.
So do we just put it right here?
Right, in a row. You can go 4 across. Minnie, you gotta have goggles on. Jamal, you can't sit there, you gotta have goggles on. Nate.
You gonna get grease on these goggles?
That doesn't concern me. I'm more concerned about your eyesight. Very good. That's correct for carbon. Now iodine's a little longer.
Magnesium, 2 minerals most important for your health are examples of alkaline earth metals. Because magnesium is solid and relatively light, it is used in fabrication of electronic devices such as laptops.
Alright, so the second group on the periodic table, how many groups are on the periodic table? Raise your hand. Raise your hand. Christian, 7? No. Vance? No. How many groups are on the periodic table? No. No. 18. There are 18 groups. They are the vertical columns that go across the table. Now the horizontal periods, how many periods on the periodic table? Raise your hand. How many periods?
7.
Raise your hand. TT? Right, there's 7 periods. So you can see that when you look at the periodic table, the 7 periods, and there are 18 groups. You can see the 18 right there. 18, everybody see 18?
But isn't there only like 3 major groups?
There are 8 major groups based on the law of the octaves. We've been talking about that with the Lily, with the electron dot. Now the second group, the lab you're doing today, concerns the second group. How many electrons are going to be found, valence electrons are going to be found around the second group? Raise your hand. How many valence electrons will be found around the second group? 2. Very good, TT. There are 2 electrons. And those metals, those metals typically desire to do what? Gain or lose electrons, Vance? Lose. Metals like to lose. You're like a metal, and that you want to lose your electrons. So today we're going to be looking at the alkaline group. It's the second group on the periodic table right here. The alkaline, calcium, magnesium, if you place them in water, they will form a base. That's why they're considered to be alkaline. What is a base? Anybody know? It's the opposite of an acid. Alright, so a base is a substance that will lose electrons and will gain a proton. You might want to write that down. We'll look at this again in the future. There are various definitions. The Lewis definition basically talks about how electrons are lost, and the Bronsted definition is how protons are gained. Bases tend to want to lose electrons and gain a proton. Now, if you're dealing with a battery, why would you want an alkaline battery to have a metal that's alkaline in it? An alkaline paste, like, or an alkali paste like potassium hydroxide. Well, the alkaline paste, like potassium hydroxide, is going to want to lose electrons. And what do you want to do with batteries? You want them to produce electrons, right? Now, the batteries have a lifespan of around 5 to 10 years. The Duracell, they're maxing out at 10 years. That is, after 10 years, it's not going to be good anymore. just because of corrosion. Corrosion will cause the interior for the battery to mix, and then it's no longer useful. Now, rechargeables are a different story. Rechargeables can last a lot longer. They say the car batteries, you can get about lifetime around 10 years from those. The reason why you can't get longer than 10 with the rechargeables, using them daily, concerns impurities. So in a battery, if you have impurities and you consistently heat them up, you can get new compounds that are formed, and those new compounds are going to affect your charge or the lifespan of your, let's say, cell phone. So if you use your cell phone for a long period of time, you notice that the charge is not working or lasting as long. Part of that would be impurities. Notice that?
I had a phone die on me 2 weeks ago. And it just wouldn't turn on.
Wouldn't turn on anymore? Yeah. Now with the Apple, obviously you can't replace the battery, so.
I tried that. No,
Can't believe
can't.
it.
It's fake battery.
Oh, is it difficult to do?
Yeah, I get free.
Okay.
I get free refurbished phones, and they use really cheap batteries in refurbished phones.
Yeah, happens. No, Carrie, it's not appropriate. Kaylee, sorry.
We're gonna need more of those.
Which one do you need?
Potassium.
Iodate? Yes.
Yeah.
How about I give you a point?
Okay,
I'll give you a
okay.
point.
Yeah, that's
I'll give you a point. See, when you're off task, it stresses me. Because then I have to, yell at you.
You don't want to.
Well, I can't. I mean, I can
You
get
don't
very
have to
mean.
yell.
See, right, but I ran this morning 4 miles, so.
Really?
Yeah, I run every
Why
morning.
would you do that?
3 to 4 miles.
What time did you have to wake up?
5. So it prevents me from, having anger issues. Because if I throw things and I yell, I get, written up, so it's bad. You give me YouTube sensation with your mixtures over here?
What?
Make sure you write down what you see.
I am writing down what I see.
You're fantastic. Pick somebody to do iodine for us, Jimmy.
Jacob Brown.
Anybody?
I would, but I don't know how to do it.
Jimmy.
Aaliyah would love to do it.
George, why don't you up in?
77, we were talking about alkali-earth
Oh,
metals.
okay. The alkaline earth metals are in group 2. They are also highly reactive. Calcium, Ca, and magnesium, Mg, 2 minerals important for health, are examples of alkaline earth metals. Because magnesium is solid and relative.
You're 0.5.
It shoots way up farther than 0.5. And then
So what you want to do,
because she's awesome.
you go into where,
This is 0.5, and then you get it out.
right there is 0.5, right? That doesn't have to be exactly 0.5.
Just around.
So that's 0.5 right there. See how that's 1 right there, so that one's 0.5.
Yeah. So how much do you put in
0.5.
on each of them?
Right. Don't cross-contaminate.
What happens if I cross-contaminate?
Your results will be...
Well, we already recorded those.
Okay. Wrong.
Cross-contaminate.
Iodine, you have the ion iodine. That would be the anion.
The number of
That's fine.
negative electrons.
That's fine.
This is the calcium. And now I'm writing the electron configuration.
But let me find the maximum numbers you can use. Go into but you have to start at 1 as 2. Just do that. Alright, now we just need
Right so far?
Yep.
Alright. Okay.
Do 4 pi, 4,
There's this from history.
4p5.
No, it's 5p. What?
Oh, 5.
5
5p5. The question we have is, how many groups are in the periodic table? Raise your hand. Raise your hand. No? 18 groups, Trey. Now, we have 18 groups in the periodic table. The alkaline is in which group? Raise your hand. I just listened to see if you pay attention to what you read. Group 2, we just said here, Group 2, right? We just read that, just see if you're paying attention. Group 2. Now, Group 1 and Group 2, Group 1 is the alkali, and Group 2 is the alkaline. They both form what in the presence of water? Raise your hand. No. In the presence of water, if you drop these metals in water, what do they form?
Solid.
No.
Gas.
Do they form acids?
Acid.
No. They form,
Electronic.
starts with a B.
Boron.
Raise your hand.
Boron.
No. Starts with a B. Not an acid, but a.
Base.
Raise your hand. Very good. They form bases. Madison, nice job. Okay, so shh, Noah. They form bases. Now here's the situation that you really need to pay attention to. Most of you took biology last year, and biology. You should have learned about acids and bases, pH, power of the hydrogen, because they talk a lot about acid rain. That's pretty important biologically. Fish cannot live in low pH solutions. They die. That's a problem. So when you put these metals in water, you form bases, and bases are electron donors. I'm going to write that down. They're electron donors, and they are proton acceptors or hydrogen acceptors. Now, if you have a battery, most batteries are alkaline. Why would you be concerned about the benefit of an electron donor in a battery? What do batteries do? They provide what?
Energy.
Or electrons. Magnesium.
Make sure you do that for everyone.
Right, so you have 4 of the calcium and strontium and barium. 0.5.
Make sure you have the right one.
Now there is an error on this sheet here where it says 1 molar at the barium nitrate. It's actually 0.2. See here? That's an error there. It should be 0.2 molar. I don't know whether it should be 1 or 2, but they only gave us 0.2.
You want us to find the specific one, 0.25, and it says right there.
It should, yeah. So this is what you're actually going to follow. This is the procedure when you read it. This is actually what you're going to do. Record your data there.
Okay.
You're going to use 0.5.
Are these the same? These are the same ones, right?
Yeah. If you look here, it says magnesium nitrate. So that's right here. Now you could do it individually, but you're going to end up using more pipettes. If you just use the same pipette and put 4.5 in a row on your well plate, and then you test down here with the potassium iodate, and you'll use a total of 8 pipettes instead of like 8 times 4.
Where's the?
If you listen to me in the beginning of the period, we changed it to 0.5.
Okay.
0.5 is what we're going to do.